Okay, good afternoon, everyone. We're back in our afternoon session where we will have 11 paper presenters for today. So we have a hectic schedule. So without further ado, I hope that the first presenter is ready. Um, okay, so the first presenter for today, the paper is about image-based crop leaf disease identification using convolutional neural network by John Marie Fernandez and Maria Art Antoinette Clarino, and it will be presented by John Marie Fernandez. Let's give him a warm round of applause, please.
Thank you, Dr. Cherry, po, for the introduction. So let me share my screen. Okay. So good afternoon, everyone. Let me start this afternoon session with our study image-based graph leaf disease identification using convolutional neural network. So by 2050, it is projected that the world's population will be at 9.7 billion, 34% higher than today's. So, to respond to the rapidly growing food demand, experts presume that there is a need to increase food production by an estimated 70% to feed the world. So, many farmers and manufacturers involved in the agricultural sector are already taking advantage of modern technology, particularly using digital tools to solve the impending food demand. So, despite these innovations, food security remains under threat by different factors, including the decline in pollinators, climate change, and plant diseases. So, globally, crop diseases have been an enormous burden on farmers. So, billions of dollars a year are spent on crop disease management to cease crop losses. So about 40 to 50% of the total crop yields are lost due to pests, crop diseases, or post-harvest losses in developing countries. And until recently, adequate technical knowledge and support are inaccessible to poor and smallholder farmers, resulting in poor disease control, pollution, and harmful research. So these losses on agricultural productivity can be prevented by an accurate diagnosis and early treatment of crop diseases. So, so what's our main problem? So, despite the vast developments and innovation in technology, farmers are still accustomed to using traditional methods in checking crop leaf diseases. So, as we all know, manual checking for crop diseases is a tedious process, yet it may lead to inaccurate results. Without the insights of experts, farmers can find themselves withstanding crop diseases with one size fits all solution that not only fail to address their problem, but often result in undesired side effects. So, with the availability of public data sets of crop leaf diseases and the development of machine learning, farmers may utilize the use of systems to monitor their crops for diseases. So, the general objective of the study is to develop a model that shall identify crop leaf diseases using a non-hierarchical flat model that maximizes the adaptive learning of spatial hierarchies of features in convolutional neural network or CNN. Specifically, the study aims to achieve the following. First, to train the model using the non-hierarchical flat model convolutional neural network with crop disease pre-labeled data from Plant Village dataset. Second, to validate the model's performance using case-fold stratified cross-validation. And third, to to compute for performance evaluation metrics for the created model and to accurately identify the crop leaf diseases test dataset. So what's the significance of this study? With the development of modern technology, so it is important for us to incorporate modern technology to the main source of our economic growth as well as our daily food. So the use of machine learning in the identification of crop leaf diseases may benefit the farmers since it can provide an automatic classification of crop leaf diseases for them. So accurate detection and classification of crop leaf diseases with will help farmers to maintain and to protect their crops from further infections and deterioration. So the scope of the study is to create a model for classifying crop leaf diseases. This model is limited to detecting the following crop species and diseases. So number one, corn gray leaf spot. Number two, corn common rust. Three, corn healthy. Four, corn northern leaf blight. Bell pepper bacteria spot. Bell pepper healthy. Potato early blight. Potato healthy. Potato late blight. Tomato bacteria spot. Tomato early blight. Tomato healthy. Tomato late blight. Tomato leaf mold. Tomato septorial leaf spot. Tomato two spotted spider mite. Tomato target spite. Tomato mosaic virus, and tomato yellow leaf curl virus. So how how did we implemented this model? We used these materials. So first, a laptop with this minimum specification, and then uh, we developed the model under the Linux operating system. So the following tools were used to build the model. So for the programming language, Python was used to implement the model. And then for the machine learning, TensorFlow, or an open source machine learning library for research and production, was used to create the neural network. So the data set, uh, images with crop disease labels were obtained from Kaggle.com. So Kaggle is an online platform where you can get open source dataset. So the plant village dataset is composed of 35,263 images of plant leaves that are pre-labeled with crop disease labels, varying from a total of 19 classes. So the figure on the left shows each examples of leaf images from the plant village dataset. So to ensure the accuracy and consistency of data, the integrity of the dataset is preserved by not adding, subtracting, or cherry picking the images included in the dataset. So the dataset is divided into three subsets. So the training dataset, validation dataset, and the testing dataset. So we follow the 64, 16, 20 train validate test split. So 22,567 images are allotted for the training dataset, 5,642 for validation dataset, and 7,054 is allocated for testing dataset, as presented on the figure on the right. So as the plant village dataset has multiple images of leaf in different orientation, so it is ensured that all the images of the same leaf are either included in the training dataset, validation dataset, or testing dataset. So overall, there is a total of 35,263 images in our dataset. So before feeding the images to the neural network, two necessary pre-processing steps are applied to these images. So first, the images were converted to its three-channel BGR color image. Then after that, these images were resized to match the size of the input layer of the neural network. From the original sizes, each image was resized to 50 by 50 image pixels. So we use the convolutional neural network in this study. So CNN is a widely used neural network for solving complex deep learning problems. So to give a brief background, it is designed to automatically and adaptively learn spatial hierarchies of features through backpropagation by using multiple building blocks. So the CNN model used in this study consisted of 5 convolutional layers. So the convolutional layers are the layers where multiple filters are applied to the input image to extract features. So in our model, 32, 64, 128, 32, and 64 filters were utilized on each convolutional layer respectively. So each convolutional layer is followed by normalization and max pooling layer, which takes the maximum value in a certain filter region. So also, to introduce nonlinearity in our CNN, all the layers in the network usually have rectified linear unit or rel activation that replaces all negative pixel values in the feature map by zero. So after that, it is followed by two fully connected layers, a dropout layer which is a technique used to improve overfit on neural networks, and a softmax layer used to normalize neural networks output to fit between 0 and 1. So the output from the convolutional layer and pooling layers represent high-level features of the input image. So the purpose of the fully connected layer is to use these features for classifying the input image into various classes based on the training dataset. So the following hyperparameters were used in all the model setup. So learning rate, 1 raised to e raised to negative 3. So optimizer, Adam, loss, categorical cross, entropy, epoch 12, solver type is batch gradient descent. So five-fold cross validation is also used in this study. So we use this five-fold cross validation to validate the performance of the CNN classifier. So the training data set is divided into five equally subset. Each fold and an assigned subset is used for the validation, and the remaining four subset is used for training the model. So the training subset is used to fit the model and to tune in its hidden parameters, such as weights and biases. While the validation subset, on the other hand, is used for an unbiased evaluation of a model fit and manually adjusting the hyperparameters. So these are hyperparameters are the configuration that cannot be automatically learned during the training. So the figure shows the distribution of the training dataset versus validation dataset for each fold. So to ensure that each class is well represented, excuse me, across each fold, the stratified k-fold cross-validation approach was implemented in rearranging the data. So we implemented an algorithm to use stratification because we all know that stratification help us with reducing both bias and variance. So uh, this evaluation metrics was computed after. So this evaluation metrics was used to determine the performance of the CNN classifier. So we have accuracy, recall, precision, and F1 score. So for the results, so the training and validation of the model was done using an hierarchical flat model. So this is to challenge the CNN model to classify crop disease label without following the hierarchical approach. So that approach is first identifying the crop first and then the disease later. So in this study, we use the non-hierarchical approach. So during the training phase of the developed model in this study, the training and validation accuracy and loss per epoch were recorded. So
Two minutes, please.
it can be deduced from these metrics if the model is underfitted, overfitted, or good fitted. So in the figure, it can be observed that as epoch increases, validation accuracy increases. So inversely, as the epoch increases, the loss decreases. So after the creation of the models, the CNN classifier is tested using the 20% or 7,054 of the original dataset. These data were kept unseen by the model during the training phase. So based on the figure, an overall accuracy of 98.742%, mean recall of 88.431%, mean precision of 89.73%, and mean F1 score of 88.408% were computed from the performance of the classifier across all folds. So fold one yielded the highest value for the computed metrics, having 98.93% for accuracy, 90.35% for recall, 90.56% for precision, and 90.28% for F1 score. So this table gives information about the confusion matrix, the accuracy, and the F1 score per class label of fold one. So the confusion matrix allows us to have a comparison between the number of predicted label versus the true label. So the figure shows the image comparison of tomato early bright, tomato yellow leaf curl, virus, bell pepper, bacteria spot, and tomato two spotted spider mite flies label. It is observed that the size of infected disease in tomato early bright and bell pepper bacteria spot are relatively same based on the image. While on the while the tomato early bright, tomato yellow leaf, curl virus, and tomato two spotted spider bite have comparatively the same color in the affected parts. So tomato early bright classes perform the lowest with 97.46% accuracy and 77.58 F1 score. In contrast, corn common rust performs well in determining its true positive and false positive. Covering all class labels, it only classified two false positive, having 99.95% accuracy and 99.60% F1 score. So the table shows the summary of performance metrics per class label. From the results displayed, corn healthy class label yielded the highest overall accuracy, 99.922%, mean recall of 99.731%, mean precision of 98.882%, and mean F1 score of 99.304%. So on the contrary, tomato septorial leaf spot produced the lowest computed value for overall accuracy, mean recall, mean precision, and mean F1 score. So the CNN classifier often distinguished tomato septorial leaf spot as tomato leaf mold. On the average, about 8% of the tomato septorial leaf spot labeled images were tagged as tomato leaf mold. So the figure 9 shows the side-by-side image comparison of the two class labels. So as observed, both leaf classes share the same color and texture. The size of the infected parts is approximately the same for both classes, leading to the confusion of the CNN classifier. So in summary, we noted that overall accuracy of the CNN classifier ranges from 97 to 99%. Also, we observed that the mean recall, mean precision, and mean F1 score span from 72% to 99%. So this study demonstrated the technical feasibility of a craft leaf disease identification using convolutional neural net. With the use of the plant village dataset, the overall accuracy of 98.742%, mean recall of 88.431%, mean precision of 89.73%, and mean F1 score of 88.408% were obtained from the performance of the classifier across all folds. So based on the quantitative performance evaluation metrics used in our model, it can be concluded that the use of convolutional neural network in identifying image-based craft leaf diseases is feasible and effective. So for future works and recommendation, the image used to train and to test the created models are from plant village dataset only. Would improve the performance of the model. The model in this study can also be used in creating a web-based or a model application where user can capture or input a leaf image and know if the crop is healthy or infected by a specific crop leaf disease. So these are the references used in the slides. And that's all. Thank you for the image-based crop leaf disease identification using convolutional neural network or CNN.
Okay, so thank you very much for that presentation. Do we have questions from the audience? Maybe we can have one question because we're running out of time. Anybody? Basically, you said it in the future work. I was basically wanting to ask na if you really intend to continue with this because as it is, it will not be useful unless we deploy it to the people who will use it, right? The farmers or whoever are using this so that they can detect it early. Are you on your way to developing the mobile app? I think the best app would be a mobile app. Are you on your way to developing that?
Yes, Dr. Cherry. So yung dataset po kasi ay from other countries. So nakikita ko po yung setup ng mga images as hindi pa siya natively dito sa atin. So ang una ko pong naiisip ay mas okay po sana na mag-collect tayo ng datasets from here in the Philippines na mas specific na yung environment ay Philippine-based muna.
So maybe
before
that's
siya
the next step. That's the next step that you should
mag-develop
have
ng
placed in the
mobile
should have
application or
placed in
web.
the future. Yeah, maybe that should have been the first step. Maybe you can create a template or something like that, or an app where they can upload so that parang control din yung pictures that you will get, ano. At the same time, parang my format or whatever, na. Maybe that should be the
Apo,
next
apo.
step. Okay, so thank you very much again, Mr. Jean-Marie Fernandez, for that paper. Let's move on to our next. Can you stop sharing your screen? Okay, let's move on to our next paper. So our next, I'm sorry, okay. Is this the, wait lang,
Hi.
wait first. I will do the introduction first. So the next paper is about building a Filipino-English bilingual knowledge taxonomy using clustering towards cross-lingual word embedding model integration of local ANR knowledge by Catherine Flores, Concepcion Can, and our presenter, Ricky Lee Menjola. Let's give him a virtual round of applause, please.
Okay, hi. Good afternoon. Can you hear me and can you see my slides?
Yes. Continue.
Okay. Hi, everyone. Good afternoon. So I will present on behalf of my co-authors and members of the project team, Ms. Buko Flores and Prof. Can. So our paper has a title, Building a Filipino Language, Filipino English Bilingual Knowledge Autonomy using clustering. So towards cross-lingual word embedding model integration of local ANR knowledge. So this is an endeavor. This endeavor is a part of a bigger project, no, on streamlining knowledge management in agriculture, aquatic, and natural resources. So this is just one part of it. Okay, so for my presentation flow, so I'll start with the rationale and the limitations of the study, and then I will breeze through the related work that we explored when we were writing this paper. We then an overview of the methodology, and then the insights are what we got in the results and discussion, and then the future work. No? So what's coming next for this study? Okay. So for the introduction, no? So this endeavor is a bigger part of a bigger project. It's a part of a bigger project, no? So this is as a part of a knowledge sharing system, no? So this baseline work is conducted to create a bilingual knowledge taxonomy for agriculture, aquatic, and natural resources, or ANR knowledge artifacts. So the situation is local AANR knowledge are currently very limited in terms of accessibility. No? Due to one, knowledge lives in silos. No? So these are fragmented repositories that reside from different knowledge creators, no, like state universities and other research institutions. So these fragmented repositories are usually unannotated knowledge artifacts, no, which makes it a bit harder to access. So a lot of it also is limited to English. Majority of it, no, despite other languages used by the communities of practice in agriculture in AANR. No. So a lot of it, of course, especially technical knowledge, are articulated in English. So as a whole, the system presents a solution to facilitate knowledge retention and transfer, as well as establish a connection between R&D's fragmented repositories. So we also thought that there could be a stretch goal. So we want to make knowledge repositories accessible in languages used by the COPs. So we want to look at also how we can make it more accessible to our local languages, no, or how we can articulate AA and R knowledge in our local languages. So as a proof of concept, so we started with English and Filipino. These are the languages that we are familiar with, and you want to classify knowledge assets accordingly. So this presentation or this paper is a tentative result and a very much work in progress. So we have three objectives for this paper. We want to look at first, we want to look if we have what's the underlying thematic structure in terms of we want to look at the underlying thematic structure using text clustering and topic models. Uh, we want to evaluate so which fits better in terms of the ANR use case. And we want to prepare a knowledge dictionary. So we want to start a Filipino English pairings of ANR scientific terms from the topic model. Okay. So we have a lot. We want to, of course, state the limitations first. No. So on this paper, we actually have someone who has a rich background on translation and Filipino language. So we also want to look closely on the language itself, not just on the text side. No. So we want to look at the insights also on the linguistic side. So we want to first, there's a gap that lies in capturing the language complexities in terms of structure, nuances, and context. So we still haven't addressed that part. So this is just the start. No? So also, Filipino and Tagalog are politically loaded terms, so which is usually used interchangeably, no? And these are also very low resource languages, no? So there are not enough resources in terms of doing digital work, no, for it. So also in terms of structure, no, it very much differs with English, no, which affects translation accuracy and further complicated by code switching among speakers. Okay. So the data used to train models are the excerpts from various content types of ANR knowledge assets. So this was collated and we tried to accommodate as much as we can in terms of content type and also in terms of subdomain of knowledge. Okay. Uh, so we want to look at, of course, related work and what we can build on. No? Of course, I want to start with knowledge codification to sa taxonomies. No? So codifying explicit knowledge is essential to organizing knowledge as a collective memory of an organization. So how do we look at explicit knowledge? So these are papers, these are publications, no? These are the ones that are tangible, no? And we can interact with as a material. So we want to organize that, and codifying it can only be done by creating knowledge taxonomies. No? These are basic classification systems that can help us navigate the logical organization of concepts within the domain. So which topics are related to each other, which are very much which will help you on the next based on this reference, which will help you next. No, so these are the things that taxonomies can address. No, so in terms of doing or creating knowledge taxonomies, there are manual approaches to, so to taxonomic construction. These are the more flexible types. But in terms of complexity, it can also reflect user consensus over time. So sometimes in terms of creating taxonomies, no, especially when you are parang a community of practice, you establish and talk about what are the concepts related to it and how do we structure it. No? So in terms of dealing with taxonomic construction for thousands of annotated documents, doing manual approaches are very tedious and will take too much time. So we have also automatic approaches, okay, which rely on statistical techniques to look at similarity among documents. So if we have nothing to start on, this is a good way to begin, no, in terms of exploring an unknown pool or corpus of knowledge. So taxonomies are also essential for supporting search and content repurposing. And we want to also future-proof our knowledge. No, we want to eventually reuse it. No, and we want to share it within our institution or also outside our institution. No, so and codifying it is just one of the ways to enable this. No, that's why creating knowledge taxonomies are essential. You want to do that over time, and you don't want to do that over and over again. Okay. So in terms of cross-lingual model implementation, so we also look at how we can also do our future work. So cross-lingual word representations are key facilitators for translation to the context of NLP, especially for low resource languages. No? So we want to provide a common representation space, so we can also access so we can also access other language of the assets in terms of looking at it on the both languages. No, it can be represented in both. So there are a lot of methods in cross-lingual embedding, and broadly classified into joint and mapping. But I will not get into that. No. Well, we do not propose an entirely new method. This will address the gap in low resource languages, no, such as Filipino, and especially for local and scientific technical knowledge that are often published in English. Which brings me to the last part of the related work. No, a lot of the corpus are usually accessible online. No, so it's sourced online, and some of it, of course, are not sourced online. No? So very few of it are concentrated on local scientific and technical knowledge, and we want to start on that. No? So usually, NLP and PH are focused broadly, no, focus on two objectives. Of course, English Filipino translation system, so better translations, no, and building a more comprehensive corpora for future NLP studies. So these studies recognize linguistic and cultural implications, no, but their corpora sources may have not been a reflection of that. But that's on a broad sense, no. So due to limited computationally focused resources on Filipino language, studies on NLP primarily focus on similar goals. A lot of it, of course, is in translation because that's where we can start, no. So with the corpus specific to AANR knowledge resources from across the country, it will help set up the standardization of AANR terms in Filipino. And extensive translation of the most common and essential words in AANR sector will help, of course, in the information retrieval in AANR, no? And of course, with the address the accessibility that we raised earlier. So this will build on national and regional knowledge resources. Okay, so for our methodology, so we sourced knowledge assets, ANR knowledge assets, and then we collected it as researchers that went through the standard NLP pre-processing procedures. So removing stoppers, punctuation, unnecessary characters, stemming and lemmatization. Okay, and then these data sets were subjected to two unsupervised machine learning methods, and both results were evaluated by quantitative and qualitative means. The corpus was also subjected to word to vexim that then translated to word pairings in English and Filipino. And the preliminary results of the POC will guide the creation of machine readable AANR knowledge dictionary, and will eventually train lingual word representation. So the generated ANR dictionary, compiled mostly in English, were translated to Filipino. So I will talk about the number 7, the future work, at the end. No? So what are the insights, no, quickly, since I'm already running out of time. First is we looked at it in terms of text clustering. So we use k-means. No? So the clusters reveal three major clusters. No? So the 1 and 2 are news and press releases and ANR events and community. A lot of the content are mainly centered on that. And when we look at the words that are they share a lot of words in terms of how they've articulated, no, yung events and of course press releases. But number 3 is very much dominated agriculture, which is crop science. A lot of the scientific and technical literature are really represented. A lot of crop science is represented in ANR knowledge. No? So there are considerable overlaps among clusters. No? And one reason might be the dominance of agriculture in ANR knowledge domain. And another reason would be there are interrelated concepts that cross AANR, no? Specifically when talking about biodiversity. So when you talk about ecosystems as a whole, no, you also talk about the subdomains in ANR, which are one of the things that we observe. No? Of course, this can still be a process. This since this is a work in progress, we want to fine tune it in terms of features, and we want to, of course, increase representative data points in ANR documents. The next result will tell us why. No, so LDA is a probabilistic topic model. So we want to expose and add the underlying thematic structure of the unannotated text. No, so we use this as a tool for knowledge discovery, both of the methods. No? So we want to show the distribution of topics among documents. So based on silhouette score, no, the best would be 7 clusters. No? Ayan. So when you see it, no, so a lot of it centered on agriculture again and crop science. No? So the main difference of the topics would be the top words that comprise it. No. Next, 1, 2, 3, and 3, 4, and 7 shows distinct dominant articulations of ANR as research and development documents. So a lot of it are extension, a lot of it are research, technical documents, and how you can understand a particular technology. No? But there's a considerable insight that we saw when we were examining the corpus. No, there's a noticeable absence of aquatic resources as a distinct topic. There's this is a reflection that there is a small representation, no, not enough representation in the ANR knowledge domain. So while the distribution of the content types are varied, AR is not usually discussed in the document. So it's not very it's not seen as a solid cluster or a solid topic. No? So I just want to breeze through. So these are the top words for uh, the dictionary sa ANR. No? So looking at the dictionary produced using the two methods. No? The direct Filipino word translation show that there are, of course, multiple loan words. No? Direct Philippine as well as multiple translations with drastically different meanings. No? May pagkakaiba kahit pareho yung words, no? Drastically different meanings. Okay, so for the analysis and how we can do this as an input, no. So as I mentioned earlier, many of the words, especially scientific and technical terms, have no direct one-word translations, no. Like halimbawa, inland. So inland fisheries are usually talked about, no. Inland, as it is translated as napapaloob sa lupa, no. So it's not just a one-word translation. No. So that's one of the things that we saw when there are a lot of loan words. No. Of course, one of the things that also ignored in terms of discussing technical knowledge is science also has its articulations in local languages that we can also explore and map in a vector space. So the point of this discussion is we want to create a workflow that can accommodate low resource languages like Filipino. And we want to do it in a way that we want a conscious inclusion in representing scientific knowledge locally. So for the conclusion and future work, so this is an opportunity to create a machine-readable knowledge dictionary for retrieval of for to help retrieval of knowledge information in a knowledge sharing system. No, so these methods resulted in a different taxonomy construction that is already set or already discussed within the R&D network. So it yielded a different structure. No, one of the interesting insights on that would be there is a gap in terms of representation of ANR knowledge. Okay, so for our future work, so this is again, as I mentioned earlier, a part of a bigger project. No, so this will integrate, of course, to the knowledge sharing system that is being developed. So to improve this, of course, we are on our way to increase our data points and better representation of ANR R&D network. So we also want, of course, to include untapped linguistic resources such as Philippine dictionaries from colonial period, and surviving indigenous knowledge, which would very much help develop a more collaborative and well-used knowledge sharing system. Uh, we also want, of course, to evaluate this taxonomy in terms of acceptability with users and also technical experts, since they are, of course, part of the community of practice. No? So future research can also address incorporating other regional languages in the Philippines to increase linguistic representation, which is very important and we should start with. And by improving localizing terms to search an English-dominated knowledge domain. So that's it. This is our reference. Thank you. If you have any questions, just raise it. Thank you for listening. And can I also request to unmute my co-author, Catherine Buco Flores, so she can also answer questions, especially ones related to language. So that's it. Thank you so much. I think I'm a bit over time.
Okay, thank you very much, Ma'am Ricky. Any questions from the audience, please? Anybody? So we have here in the Q&A from Joseph Imperial of National University. Any method used to evaluate the K-means cluster results or cohesion or of supporting topic words to topics? Did you use any method to evaluate the K-means cluster results or cohesion of supporting topic words to topics?
Yes, of course. For text clustering, we used the silhouette score. So it's just average, no. Maybe a lot of it because of course shared words, and we still have to examine it so we can produce a better clustering of the documents. Silhouette score is the one we used.
Okay. Do we have any other questions from the audience? What about from our panelists? Okay, I think you have basically mentioned, including the future work and so on. So I think it's pretty clear as of now. So thank you very much again to Ms. Menjola for presenting their research. Okay, so let's move on to our next speaker. So we have the next topic is about deep learning approach to land cover classification using multi-temporal Sentinel-1 SAR images of Kinali A watershed by Concepcion Can, Rex Victor Cruz, and Danilo Mercado, and the presenter Aldrin Joseph Howe. Let's give them a round of applause, please.
Hello.
Yes, we can hear you.
Okay. Hi, good afternoon. I'm Aldrin Joseph Howe. I'll be presenting this paper on behalf of my panel and my advisor. So I'm from the Institute of Computer Science of the University of the Philippines, Los Baños. So
can we request you to please turn on your, can you turn on your video or it's not possible?
Of course, sorry. Video. Yeah. Okay na po. Hello?
Yes, we can see you. Thank you.
Okay. So to start, the United Nations Sustainable Development Goals for 2030 is a call to all countries to promote prosperity while protecting the planet. So some of these goals include zero hunger, clean water. So this involves agriculture, hydrology, clean energy, sustainable cities and communities, which is urban planning, climate action, disaster risk reduction, and terrestrial biodiversity or life on land. So an essential part of achieving these goals is observing and measuring the Earth's surface and how it changes. So these fields are usually use land cover information. So given this, how do we measure, or how do they usually measure or observe the Earth's surface? So they use remote sensing. So there's two types of remote sensing. First is an active remote sensing where where a sensor pulses or emits a signal and then reads what comes back to it, essentially a radar. Another is by using a secondary source of light or signal. So in this case, the sun. So the sun will emit light and a sensor will read what bounces off the surface. Okay. So given this, what's the problem? So some sensors are sensitive to cloud interference. So this renders this image taken by a satellite unusable. So since this is a satellite, it has a fixed orbit or fixed number of days where it comes back to this area again and takes an image. For example, this Sentinel-2 image from the European Space Agency has these bands, but due to cloud cover, most of it is unusable. So if I recall correctly, for the whole 2018, almost 50% of the images taken for the whole year were like this, where cloud cover is persistent in the area. So for example, this is a red, green, blue color composite of this area. But there are also sensors that are weather independent. For example, this is Sentinel-1 from ESA. So it has a 10 by 10 meter resolution and uses synthetic aperture radar. And it takes images every 11 days. So in a year, it takes around 31 images. But as you can see in this image, it has limited bands. It's not as much as Sentinel-2. So specifically, so what's the problem? The problem is with limited high-res satellite images that can be used for land cover classification due to persistent cloud cover. And given the first problem, change analysis using different land cover maps from different inputs made using different classification methods is not ideal. So given this, this study has three objectives. First is to implement a 1D convolutional neural network that utilizes the consistent availability of Sentinel-1 SAR images or maps. The second is to measure the effects of adding combinations of the original bands to improve the accuracy. So the idea is to generate more features so the model can learn from. Third is how does it compare to other classification algorithms that is currently being used for land cover classification. So let me describe the region of interest first. So this is Kinali A watershed in Albay. So it includes some parts of Mayon volcano, Mount Masaraga, and all the rivers and all the streams inside here drain into Bato Lake. So this is a watershed. It is approximately 53,000 hectares. So the National Mapping and Resource Information Authority of the Philippines, so they produce official ground verified maps. So they go personally to these areas and check if what they have classified is correct. So for the whole Philippines, I think there are 15 land cover types, but for the watershed, there are 10. So most of the watershed is perennial crops, which this area colored in blue. These are permanent crops, so fruit trees, coconuts like that. And annual crops are colored in red. These are rice, corn, sugarcane. Built-up areas are cities or buildings, roads. Then there are some closed and open forest in the parts of Mount Masaraga. Okay, so how did we approach this? So the idea is for each pixel, for each time step, we can build a graph like this with each line representing a band of image. So each pixel will be fed into a model that can learn classifying features. So why a CNN? So why deep learning? So the idea is by using deep learning CNN, that training data goes through multiple layers of transformation, convolution, and it should learn usable, identifiable, or distinct features that can be used to classify each pixel. So training and selection of training points, homogeneous patches of land were selected using the NAMRIA map earlier and Google Earth. So for example, this box here is all inland water. This part is classified as marshland, and based on Google Earth, it's land, but using this base map, it's classified as water. These are classified as closed forest, and these are classified as open forest, and so on. So when we extract all the pixels inside those boxes, there are 133,000 in total, split into 70% training and 30% testing. So now that we know which points are labeled and we extracted the values for each band for the whole year. So there are 31 images with 8 bands. So these first 2 bands are native to Sentinel-1. These 3 are feature generated or derived bands, and these are from other sources. And so from Sentinel-2, a 1-year mosaic and elevation data were also added. For the architecture that was used, so several configurations of this were tested. This was tested, and this was the configuration that was observed to produce the highest accuracy, ensuring the overfitting was avoided. So almost the whole project was done using Python, from data retrieval to visualization. So Google Earth Engine has a cloud GIS API, but I used it to retrieve
Minutes.
the data. Then pre-processing was done using GDAL QGIS and GeoPandas for pixel alignment, resampling, the data selection, extraction. Then the architecture shown earlier was described and was built using Keras. And then after the model was trained, a sample area all the pixels inside the sample area were classified and was visualized, were rebuilt using OpenCV. So this was the we classified all the pixels inside this 8-kilometer wide area. So this was the result. So on the left is Google Earth imagery. So it's a mosaic from multiple time periods. So it's clear. But on the right, you can see at the center of the image in red is the town proper of Ginubatan. Red line going to Kamalig, and then some roads and were detected. It's surrounded by this blue area, which is annual crops or rice corn, and at the bottom is perennial crops. So this part. So a river runs through it, colored in yellow, but some areas, but it is not continuous since some pixel, it might be not be more than uh, 10 meters in width. So it's not continuous. This area is a mixture of grassland, shrubs, and mm, grasslands and shrubs. So zooming in more in a 1 kilometer wide area, uh, most of the image is annual crops. As you can see, these are rice fields, but an irrigation runs through it, colored in yellow, and then there's a road colored in red. And a small community is detected on the left and the upper right, here and here. So looking at the numbers, it produced a map with an overall accuracy of around 94%. The highest classification accuracies with inland water and annual crops, but the lowest were brush and shrubs, closed forests, grasslands, and open forests. So I asked for advice regarding this from remote sensing and GIS practitioners, and the advice I received was they usually just group these two, so brush, shrubs, and grassland, and closed forest and open forest, depending, of course, on what they're trying to do. But usually, uh, they have the distinction between those are vague. So I also did some experiments regarding scenarios. So first, I also fed the data into an SVM. So it gave slightly lower classification accuracy, and also tested two scenarios where feature generation, where I tested adding and removing feature generation. So for the neural network deep learning approach, the results were the same, but for SVM, feature generation increased the accuracy by 2%. So keeping these objectives in mind, uh, in conclusion, the method can produce high accuracy maps that had the highest classification accuracy with inland water and annual crops. So annual crops can be attributed to the temporal evolution of the crops, uh, how signal or how the crop changes throughout the year, going through the cropping cycle. So from land prep to planting to harvest, so it changes the most. Second is, given the data set, feature generation did not help the uh, convolutional neural network. And the third is that the neural network produced higher classification accuracy than an SVM. So, as usual, when you try to find answers to your initial questions, you'll often end up with even more questions. So, first, how can we move forward from this study? So, first is to use spatial information, so increase the dimension of the neural network. How does a pixel's neighbor affect, help classify each pixel, so the neighborhood of the pixel. Second is, since feature generation did not improve the accuracy, what if we add more unique information? So for example, from drone images, from Diwata satellite. So the challenge is to find other sources of information. Third is, since it did well on agriculture and annual crops, how can it different, if trained properly, can it identify different crop types or stage of growth? And the last is, can this model be used in other areas? So if it's trained there, can it be used in the north, for example? And last is, I didn't put that, is automation, since in the earlier slide, all the workflow was done in Python. Can it be automated from data source to data consumer? So that's it, and thank you very much.
Okay, thank you very much, Sir Aldrin Howe. Do we have questions? We do not have questions in the Q&A. Do we have questions from the panelists? Anybody from the panelists? I do not know if this is related. Let me just ask this question. Some of our students in CIT, they wanted to do something like, for example, it will go in, basically it will just count, for example, the number of coconut trees, for example, in a particular area, and then later on, depending on how good the images are, maybe you can detect, for example, if there are diseases, for example, on the trees. Can the particular technique that you use be used in that particular kind of application, or not necessarily?
Regarding disease, ma'am,
counting, for example, the trees, for example, in a particular area. The coconut tree.
For counting specific trees, ma'am, usually it's object-based.
Okay.
So one tree, but you can use, for example, statistics like for a 10 by 10 pixel, usually there's 2 trees, for example. So you can assume that for each pixel, there's 2 trees. But
okay.
for count po, usually object-based po siya na.
But what about, for example, yung issue right now, because that particular, where they got the material that they put in the Manila Bay, kasi it actually came from Cebu, it's near our area, so if you look at the, can that particular, be able to detect, that particular cover here in, I think it was in Naga, where they got the material that they put in the Manila Bay. So makikita mo yung, yung area, I do not know, no?
Depending po yun sa, share ko lang po yung screen, sa band ng remote, ng source.
Yes, that particular,
so for example, yung sa trees are sensitive, yung sa green band. But if there's cloud cover, meron din pong sources na for, example, sa tubig, sensitive yung mga sensors. So if we can incorporate that data, gagamit yung methodology to.
Magagamit yung methodology, right? If you want to determine, for example, what's happening in the Cebu mountains, for example, something like that, no?
Pag-recede ng land, yung mga ganun po.
Yeah, okay. So anyway, thank you very much, Sir Howard. Do we have questions from the panelists or from the audience? Okay, if not, let's move on to the next.
Thank you.
To the next speaker. Thank you very much. So the next topic is about Verde. Okay, greenhouse fruit monitoring system. Is this the, no, this one. The pest infestation predictive device by Kenneth Serrano, Francis Roel Aquino, Benjamin Jr. Dampil, Bettina Chodoro, Asel Casal de la Cruz, Juvie Cruz, and it will be presented by Ron Jake, Manansala. Okay.
Okay. Good afternoon. I'm Jake Manansala, and today I'm going to present about pest infestation predictive device. Rice is an essential crop and a major source of food in Asia. It provides 20 to 40% calories consumed in the Philippines. However, it is the rice if the rice attacks by different insect pests, it may lose its quality and quantity. Therefore, a top priority here is to find an effective method to reduce the level of infestation by this pest in the paddy field. Because nowadays, our agricultural resources such as paddy field gone through a long process of planting and harvesting to provide an rice, which is one of our daily needs of the people. So the purpose of this study was to develop a device that would help to simplify a task and prevent a long-term process of testing and insecticides in the paddy field. What is the problem? The problem is the manual monitoring and estimation of density of pest insects. Objectives. The objectives of these studies are to design and to develop a device that can detect the level of infestation inside the rice field. Next is that can estimate the amount of density and insects within the field. Third, to identify what types or kind of insects are in the rice field. So in this study, the way to detect the level of infestation in the paddy field is by estimating the total number of insects detected by the camera. So there is an corresponding amount of insects to be set in the program to determine if the number of insects are in the medium or high level of infestation. Methods. Collecting data by survey and interviews. The researchers used a descriptive method to gather information by way of surveys and interviews. The researchers made a questionnaire that can help and supply a strong evidence and information in their study. Descriptive research is defined as a research method that describes the characteristic of the population or phenomenon that is being studied at the general associated with survey, historical, content analysis, and qualitative data. Next is experimental method by software and hardware. In software, the software programming stands as a brain of this study. It provides commands and instruction on how to enable each component to function properly so that the result of this study is well executed. So the researchers decided to use Python because it is the language of the device, which is the Raspberry Pi. And it is fits to their algorithm called the HR cascade. What is HR cascade? HR cascade algorithm is used in this study for training the collected database for real-time detection. An algorithm has 4 stages. First is the HR feature selection. Second is the creating integral image. Third is the ADAPUS training. And fourth is the cascading classifier. Hardware. This figure shows the whole process of the device. The system of the device is embedded with Raspberry Pi computer powered by the DC source 12 volts battery through a solar energy which harvested by a solar panel. 3 cameras are networked within the Raspberry Pi that simultaneously detects and classifies insect pests. Each camera is connected with LED indicator, LCD classifier display, that identify the name of the detected insects. Also, we have here a GPS or what we call GSM module that when it reaches the maximum level of threat, it will notify the farmers through SMS. This this is the actual photo of our device. This is the solar panel, 3 device. Each device has a camera and a presentation of prototype. This is LCD display, LED indicator, and the charge control. Insect detection, density prediction, and threat level detection. First, we MCU on or the Raspberry Pi on, then the camera. In the detection, insect detection, when the camera detects an insect, the LCD will display an output of all the insect it sees in the field, and insect name will appear on the LCD. While the level of threat start when the camera detects no insects, the LED green will turns on and return to the operation loop. Then next, when the camera detects a medium level of threat, the orange LED will turn on, then not send a notification to the farmers that there are a level of threat in crops or in the field. So next is when the camera detects a high level of infestation, the red LED will turn on, then also send a message to the farmers that there is a high level of infestation in that field. Kind of insects in this study we based on 4 common insects found on the rice farm. The grasshopper, the shorthorn hopper, the rice stem borer, and the rice bugs. Insect detection. In insect detection, you can see how accurate the device is at detecting each insect. There are 5 trials conducted to improve the accuracy of the device detecting insects. Can be seen here that from the first trial up to the last trial, the detection insects has been improved. While in density prediction, we have positive detection and false detection. In positive detection, there's the insects that the device detects correctly, while the false detections are the object that the device doesn't need to detect. Next is conclusion and recommendation. Conclusion, based on the outcome of this study, the use of pest infestation predictive device can be beneficial to the paddy farmers to simplify tasks and prevent long-term pesticide evaluation. It is helpful particularly to the paddy farmers in monitoring and the insects that destroy the crops. Then in the recommendation, for the future researchers who want to improve and develop this study furthermore, the researchers recommend the following for the future development. First is the higher percentage of accuracy in terms of identifying the insects. Second is the database for the set of data. Third is automatic spraying for pesticides. And fourth, and the last, higher accuracy for detection. Okay. Thank you for
Thank
listening.
you very much. Yeah. Thank you very much, Ron Jake. No? I'm just curious because can you show again your we do not have questions here in the Q&A, I think. Yeah. Can you show your again the setup of your of the testing so it was done under a controlled environment, right?
Yes po.
This one. So did you try to do the same test in the field?
Yes po, ma'am. Kaso po, nung mag-present po, ano na lang po kaming gumawa ng prototype dahil po dahil po hindi po kami makapag-present sa field, pero nag-try po kami sa field. Ano po?
Yeah, so it's okay naman. It's a proof of concept. But computer engineering, are you computer engineering students? Or?
Yes po.
So it's computer engineering. That's why you spent time developing the devices as well as the software for it. Computer engineering basically. No? So what percent of the time was parang involved in developing the equipment itself?
Ma'am?
What percentage of the research was parang involved in development of the equipment itself? The setup, because you have the setup, you even have a solar power device there, and then you have the drone camera. So you developed that machine, right? Did you develop that machine?
Yes, ma'am.
Did you consult farmers? Because I was wondering how to actually deploy it in the actual setup. If it's a field, for example, and you want to cover the field itself, how will the particular equipment stand, for example, the elements if it's in the actual field, but because it's a bit big. Anyway, you don't want to, because you weren't able to do the field testing. I was just wondering how it will actually be deployed so that it's useful later on. Anyway. So anyway, I think that if the software itself, for example, that detects, for example, the devices, you were able to show that it was able to successfully detect them anyway. So do we have other questions from the panelists or none or not? Okay. So if none, thank you very much again, Ron, Jakeman, and Sala. Okay, hopefully you can basically develop you can continue with this and consult farmers on how it can help them in the actual field later on so that the result can be useful. Thank you. Let's move on to the next speaker. So we have Verde, greenhouse fruit monitoring system via image processing. So most of the researches presented today are related and a lot of them on image processing. So this research is done by Aldrin Colapo, Art Irene Lanzon, Lawrence Manialak, Jonathan Cortez, Acel Castle de la Cruz, and RB Domingo. And it will be presented by Joshua Kuyugan. Is this the same ba? Is this, yeah, okay, no, okay. So, are you here? The next speaker? Okay, sorry, I think I made a mistake. Who's the next speaker?
Me, ma'am.
Joshua Kuyugan, so that's correct? Is it correct? Okay, thank you.
No. So, can I start na po ba?
Yes, please proceed.
Okay. So, can you see my slides po ba, ma'am?
Yes, you can.
Okay. So, to start the afternoon off, good afternoon, dear panelists and students and my fellow attendees. My name is Joshua Kuyugan, and I will be presenting our study entitled Verde, which is a greenhouse fruit monitoring system via image processing. Now, just a bit of a background on why we chose the name Verde, ma'am, is because of the predominantly of two colors, that would be verde and V for the velvet red, and the verde for the color of the leaves of the trees. Now, This study was, we came up with this study because of the problem that we realized of overpopulation, which is, as it may not seem so today, because we still we're still benefiting from the powers of modern technology, right? And developments in medicine and improving our way of life for increasing the lifespans of humans are being developed continuously. Now, scientists have said that the Earth, our habitat, because overpopulation in its definition is defined as uh, a population that exceeded the maximum capacity of its habitat. So in that definition itself, scientists have concluded that since the Earth's maximum capacity is only about 10 billion, and we are, I think, if I'm not mistaken, in 2020, we have about 7.8 billion humans living here on Earth. So if I think all of us can see that in the near future, with all the advancement and everything, us reaching that 10 billion humans on here on Earth wouldn't be far off. Now, to address this problem, we decided to tackle this problem by first and foremost fusing two different technologies with each other, and that is first is the greenhouse farming. Uh, Greenhouse farming is the uh, technique in farming wherein uh, certain certain aspects of farming are disregarded, like seasonal crops or uh, the needs of the plants, for example, wherein fertilizers or water is provided continuously without in a controlled environment, which allows the crop to bloom further and provide more yield to the farmers. Then the most popular technological aspect today, which is the Internet of Things, wherein everyday objects or tasks and other devices are connected to each other seamlessly. Now, to fuse these together, we came up with this study. So, in the near future, if certain conditions are met and we do reach 10 billion, since uh, as we all know, we won't really opt for the more brutal route of actually decreasing the population. We can only move forward and keep moving forward uh, with each other, hand in hand. So here are the supporting articles for what I've said, since the first one is that greenhouse supports that greenhouse farming do provide yield higher than the normal methods of farming, which is in the field under the harsh conditions of the weather, the pests and other things. Then the second article is was said by David Slaughter, a professor of biological and environmental engineering at University of the UC Berkeley, Davis. We have to address the population growth, climate change, and labor issues, and that has brought a lot of interest to technology. Since, according to what he said, uh, that we have to address problems that may come up in the future to prevent them from providing more damages than they can cause already. Then the third one is the how easy it is to actually implement technology into farming and our other aspects on our everyday life. Since technology does improve and uh, improves our way of life, and it makes things easier for us. That's the simplest way I can put it. Now, the the test subjects that we chose are the tomatoes, of course, which are the most popular greenhouse plants in the planet, since they are widely used for their simple needs, and they provide higher yields than other plants. Then the objectives of our studies are three simple objectives, which are to correctly detect fruits and notify the end user, which can be either a farmer, a backyard farmer, or anyone who might come across our study or want to farm on their own free time. Then lessen the amount of work for the end user, since farming does require a lot of tasks and time. It is time consuming because you do need to care for the plants, provide for their needs, and our study, since it's IoT, we can provide those needs we can provide those needs even if the user isn't around to actually tangle with the plants. Then naturally, which is to that the feature which provides a real-time video feed from a mobile application. Now, this is useful because, as we all know, we do need to monitor these plants, since we are taking care of them and we want them to grow, want them to yield. So if there are problems, since our system still can't mingle with either typhoons, what if the enclosure was damaged by a typhoon, or certain pests came up on the enclosure, at least the user would be able to see that, then provide a helping hand in removing these or fixing these problems. Then our methods for that we use are simple, which is we collected data by interviewing a couple of greenhouse farms businesses here in Pampanga, mainly Green Gold's farm located in Mabalacat. We interviewed them about the limitations, the problems that may come up, or the things that we can improve on upon by providing them a system such as this. Then the next one is that we gathered data about similar studies that might have been already published through the internet, because as we all know, uh, there are a lot of people on earth, so it's only natural that studies like this are common. And we wanted to have a uh, background or some material that we can improve upon. Then the experimental method, which we use for adjusting the variables that we have on our study, just like the positive and negative images, the data, the values of certain pressures, the pressure for the water, how much fertilizer, and so on and so forth. Then next one is okay. So the next one is the image processing algorithm, which we use. Now, why did we use higher cascade? We use higher cascade mainly because of the time frame that we were given to produce the study, which was fairly a bit. It was shorter than the average thesis production. So we opted for the easiest way of procuring an image processing model, which was higher cascade. Now, higher cascade is a simple image processing machine learning algorithm which uses or detects features using these features, as you can see in the video, if we can play this video. So what you can see there are the higher features wherein it's detecting distinct features on the image. It can be used, it is predominantly used for detecting faces and other everyday objects, but mostly faces of people. Now, in training these model, we use about 6,000 positive images and 7,000 negative images. To delve into this, what are these positive and negative images? The positive images are the pictures or images of the crops, which are the fruits of the tomatoes, not the leaves or anything else. Then the 7,000 negative images are the images of the uh, background noises or images like leaves, plants, other plants, water lines, tubes, and other things that you wouldn't not want the system to detect. So here in this next slide, I will be discussing the flow of the our system. Now, higher cascade does provide some limitations because it can't really detect colors. It can only detect distinct features of objects, mainly tomatoes being in a spherical or circular shape. Now, we came up with a method of pushing through this problem by simply masking or blocking certain colors depending on the depending on what type of tomatoes we want to detect. For example, if we want to detect a ripe one, we would simply block every color uh, that is not the color red, which is when the program consequently detects it, it will only show the circular shape of the ripe tomato, which is on an
5 minutes.
HSV range. Then it will it will do it will that same method was applied to the other types of ripeness, which is green, yellow, which is the middle one, then the ripest one is the red velvet one. Now, the third one, the next slide is how our system actually works. So first, start by connecting the water line, of course, for the needs of the plants. Now, MCU turns on, camera turns on, so on and so forth. Then it checks. We set the timer if every day it waters the plants on morning and in the late afternoon. If in the middle of that it detects that the soil moisture dips below a certain amount, then the system will provide the water needs of the plants. This is also the same for the uh, fertilizer needs of the plants. Now, after watering, it will then proceed to detect fruits, then notify the user. Then these data are stored in databases. Well, the database that we use is actually Firebase, which since because of the time frame, we opted to use Google's Firebase database to make sure that everything works smoothly. Then here's the connection. Now, we did provide a redundancy method for notifying the user since, as we all know, our internet here in the Philippines isn't really that reliable as it loses connections from time to time. We can't really say when. So we provided a redundancy method for notifying the user by optimizing for a uh, text messaging system or a module. Now, here is the flow for the system wherein we get the feed from a Raspberry Pi, then the data is recorded by the Raspberry Pi through the Firebase, then sent. They are all sent to the uh, mobile application. Now, the mobile application, I will discuss that later. Now, so here's the fertilizer system flow. I'll skip that since I am running out of time. Now, here are our results. As you can see, our system is far from perfect since it still has that 5% noise on the last test that we did. And although it did detect 7 of our 9 test fruits, it still has a long way to go from being perfect since there's still a lot of factors that can affect this system, which is the brightness of the image, the angle of the image, how covered is the fruit, how visible is the fruit. And since you can see here, it still detects edges, which can be similar to spheres or tomatoes as tomatoes. So here it is. It detected, then it marked the ripeness of it. Then moving on, we have the mobile application. So the mobile app was developed in in the Android Studio. We use the Java language to develop this app. So here you can see the main menu wherein cameras set by the user, or cameras that are being broadcasted by the Raspberry Pi are feed through here. So the way of connecting to these cameras is via HTTP, and wherein the Raspberry Pi broadcasts the cameras in a specific IP address port, mainly in the 5001 port, and so on. Then this application also contains the data values on the soil moisture, and if the plant backs or the layer has been watered. Then the next one would be our conclusions and recommendations. Now, as we did meet, thankfully, we did meet the requirements of our panelists. It was concluded that the system was effective with a 88% accuracy with only a 5% noise detection, false detection, if you may. Now, for the further recommendation, we do recommend that since 4G is the new fastest connection, and since 5G has already arrived, we can safely say that they can use 5G to further make the connection seamlessly and without any lag. Then they can also improve upon the image processing model by using higher, more dependable or more complicated way of training the algorithm, which is either TensorFlow or increasing the data, providing a more accurate strings of data and a larger amount of data. So that's it, I think. And thank you for listening. And if you have any questions, I'll be glad to answer any of them.
Okay, thank you very much, Mr. Joshua Koyugan. Do we have questions from the audience? Okay, I think this is related to the previous exercise, and you belong to the same community. Do you belong to an agricultural school?
No, ma'am. We belong from Daosu. It's an engineering school.
It's primarily an engineering school. I was just wondering, the motivation for the research, is this a pain point of farmers? For example, did you consult farmers, and did they say that there's a need for this, that it's a pain point for them?
Well, that's also an added reason, ma'am, because when we went to interview Greenbelt's farm, they did provide some problems that we address here with our study, and we also address a problem that we predicted that might come up in the near future, because as we all know, overpopulation is a deadly thing, since it can really damage a community for the lack of food, the lack of needs. So in addressing this problem, we wanted to give farmers or users the ability to grow their own food with the less time of work, and not putting that much work, because as we all know, we're all busy and we can't really farm that much and provide the needs of these plants.
Was this presented to, for example, greenhouse farmers?
Yes, ma'am.
Okay, and how did you do some sort of usability or parang test, acceptance test or something like that?
Since we finished the study on the what do you call that? We conducted an online interview and an interview on hand, because the device that we developed, our enclosure is a bit big, ma'am. So it's not really that transportable since. So what we did is we filmed the device, then we showed them, then we provided the programs to them. Then after that, they gave it a thumbs up on that it is workable, and they would think about using it or something.
What about comparing it to existing systems? Do we have existing systems? How would you compare it to existing systems out there?
There was a study done by, I think, two Indian researchers. They developed also a tomato detecting device, but they only detected about I think if I'm not mistaken, 83% of the fruits. But since, as I've said,
Yeah, in relation to that, I have a question here, a technical question from the audience, and let me just read it. So the question is given by Jasper Katapang from UP Manila, a graduate of UP Manila. Parang he said that since the confusion matrix was not shown, it's hard to find out which of the classes contribute to majority of the misclassification. Regardless, have you considered data augmentation of the class that causes most of the miscalculation to try and minimize it?
yes, ma'am. So in just that question, as I've said, the data can still be improved and trained more since it can still be improved upon since the data that we fed through the trained actual model was still it was rudimentary, if I put it in simple terms, since we had this less amount of time to develop this model.
Okay, so anyway, that's the end of I think the Q&A. We're running out of time. Thank you very much again to Mr. Kuyugan for the presentation. Let's move on to the next presenter. So then the next presenter in the lineup is not available, so we move on to the next. This time it's support vector machine algorithm in fish kill detection to be presented by Marizal Villanueva. You may have the floor, Marizal.
Your sound is not working, Maricel. Your microphone, we cannot hear you. Hi, Maricel, your microphone is not working. It's on, we can see, but it's on, but it's not working. There's no sound. We can't hear anything. The audio problem, maybe you need to fix that. But
Should we move on to the next speaker, sir?
yeah, sure.
Okay, we will move on to the next speaker so that we are giving time for Ms. Marizal to fix the issues. So actually, the two of the next speakers also are not present, so we move on to Vlocate. Is Oriel Melendres, please prepare. So the next paper is Vlocate, web-based vulcanizing shock locator for the 2nd District of Oriental Mindoro. To be presented by Mr. Oriel Melendres. Are you in,
Sir?
Yes, ma'am. Wait. Kita po ba yung screen ko?
Yes, it can be seen. You can do the slideshow now.
So, bakit nawala? Wait lang po.
Click the, try to click the screen.
Click mo lang yung presentation view.
Presentation.
Kita namin na.
Okay.
Yan, there.
Hindi.
Ano? Yan ang first slide mo ba? Mapa?
Okay na po. Nakikita po.
May
Yes.
mapa. Is that it? Okay.
Good afternoon. Good afternoon, everyone. I am Yoriel M. Melendres, a BSIT faculty of Mindoro State College of Agriculture and Technology. On behalf of my co-authors, I would like to present our study entitled Bilocate Web-Based Vulcanizing Shop Locator for 2nd District of Oriental Mindoro. For the introduction, people nowadays really love to travel, and when traveling, roadside emergencies are inevitable. One of the most common problems encountered when traveling through land vehicles is when having flat tires. 27% of the roadside emergencies are tire-related. This statistics showed the importance of small businesses like vulcanizing shop. The vulcanizing shop is a classic Filipino business typical in the province like Oriental Mindoro. The standard service offered by vulcanizing shops is repairing punctured tires of any land vehicles like car, motorcycle, and bike. Some vulcanizing shops also offered small engine repair, automotive works, and selling common car spare parts. Most of the travelers use navigation mobile applications to reach their destination. However, not all information is available on the leading navigation app, specifically those local and small establishments like vulcanizing shop. This motivates the proponents to develop a web application that can help quickly locate the nearest vulcanizing shops. But since most of the vulcanizing shops are not selling common spare parts, the proponents also included car and motorcycle spare parts store. For the objective of this study, develop a web-based navigation app to easily locate vulcanizing shop and car motorcycle spare parts store in 2nd District of Oriental Mindoro. Second is to ease the burden of the driver locating vulcanizing shops or spare parts store in an unfamiliar place. Recognize the significant role of vulcanizing shop in the community and to promote their services. And last is evaluate the system with ISO IEC 25010 support quality standard criteria. For the data gathering, the proponents conducted a survey to all vulcanizing shops and motorcycle spare parts store near and along the nautical highway of the 2nd District of Oriental Mindoro. This is to know the coordinates and the products and services offered by each shop. And the figure shows the number of vulcanizing shops and spare parts store per town. For the development method, since the system is the study is a developmental research, the proponents use rapid application development. it has four major phases. First is requirement planning. The proponents define all the requirement specification like functional, non-functional, user, hardware, and software requirement. It followed by the user design. It is composed of three steps. First is the prototyping, uh, pro- prototyping, testing, and refine. This this part, those parts are sequential and iterative. After that, move to the construction. Rapidly develop the system with full functionalities, considering all specific requirements. The proponents primarily used code igniter and leaflet JavaScript library for mapping. Next is the cutover, the final stage, which is also known as implementation. It is in this part, the proponents done some polishing on the features and functionalities of the system. And next is the system evaluation. The proponents adopted the four criteria of ISO 25010 to evaluate the system. Those criteria are functional suitability, performance efficiency, usability, and security. Next is the respondent. The respondents are composed of 60 respondents, 10 BSIT faculty, 20 drivers, and 30 Riders Club member. And for analysis, 5-point Likert chart was used and average weighted mean. For the result and discussion, let me show you the screen record of the system output. As you can see, upon opening the app, the map and different markers was automatically loaded. The blinking blue-red marker indicates the current location of the user, while the green marker indicates the spare parts store and the blue marker is the vulcanizing shops. The user location marker will timely move, as you can see on the screen on the recorded video. Once the user taps a marker of the spare parts store, it will show the name and services offered, and the app will ask if he or she wants to route. Upon clicking yes, all other markers will hide. The app will only show the targeted spare parts store, a red line which serves as guide, and the distance of the user to the targeted shop. As you can see on the screen, it will timely move the user. This process is also the same when the user click the vulcanizing shop marker. Shows the services offered. Then the user can zoom in, zoom out. That is the system output. For the evaluation result, system evaluation result, for functional stability, 4.3, for performance efficiency, 4.4, for security, 4.5, and for usability, 4.3. It shows that the system is functional, usable, and feasible for implementation. And to highlight the compatibility of the system, we also recorded the minimum specification of the smartphone used in the evaluation. They used two operating system, Android 5.0 and iOS 7.0. For browser, Google Chrome and Safari. The minimum display used in evaluation is 4.0 inches. RAM is 2 gig and CPU is 1.8 gigahertz dual core. For the conclusion, the existence of vulcanizing shop in the province like Oriental Mindoro is a great help to travelers having roadside road emergencies like flat tires. The development of VLocate is significant because it provides the nearest location of the vulcanizing shop and car spare parts store in the 2nd District of Oriental Mindoro. It also recognizes the importance of vulcanizing shops and can promote their products and services. And last is the VLocate app was found to be user-friendly, functional, and usable based on the evaluation conducted. For recommendation, the system evaluation only focused on its usability and functionality. Thus, the proponents recommend further tests like beta testing to identify real problems and make some improvement. For future works, for the improvement of the system, it is recommended to widen the scope of the map since not only in 2nd District of Oriental Mindoro the problem is present, and make it offline since some place has a weak internet connection. Here are the references used, and that's all. Thank you.
Thank you very much. Do we have questions from the audience? You know, I will ask the question na lang. I'm also a driver, so I can see the need, no? I'm just wondering if number one question is how easy it is to adapt the system to a different location.
Actually, the system, for now, the application is available only for the 2nd District of Oriental Mindoro. Any smartphone can be used since it is a web-based. Hindi po problema yung kung ano operating system meron.
Yeah, but I mean ba, like, is the system designed in such a way that I will put in, for example, information about the vulcanizing shops? Kunyari, I have a database of vulcanizing shops and location, and I will just basically plug it in and your system will work right away in a different location. Was it designed like that? I'm just wondering, because if you design it like in a way that parang siyang plug and play ba, that it will, given the data, it can work in a different locality ba, location or something like that. So right now, it's basically for the 2nd District of Oriental Mindoro. I'm also wondering that maybe you can suggest these 2 ways. I do not know if Waze has this, but maybe, Waze can incorporate data about vulcanizing shops. It's useful for the Philippines because maybe in other countries, they will just go to, how do you say this, yung mga gasoline stations or something like that. But I think this is a Philippine problem.
Yes.
Yeah. And especially yung mga parang mga rural areas, for example, something like that.
Yes,
so siguro yun yung recommendation ko, if you can look at the architecture of your system to make it easy, adaptable to. I think there's a question. There's somebody raising her hand here. Sir, there's somebody raising her hand.
It's Anjanette Aline Galang. Ma'am Shena.
Yes po.
Can you promote Miss Galang as panelist?
Miss Galang, okay.
Or allowed to talk?
Okay po. Okay na po. Talking permitted. Miss Galang, please unmute yourself po.
Waiting for Ms. Galang, there's a question in the Q&A, and I actually thought about this while he was presenting this. Do you have a rating system for the vulcanizing shops? Parang feedback, a way to provide feedback rating.
Actually, hindi po siya na-include dun sa system development. Pero for further improvement po ng system, pwedeng recommend po na including yung feedback gathering about our ratings for vulcanizing shops.
Okay.
I'm Cherry. Good afternoon.
Yes, sir. Sir Randy.
May I ask the proponent, the researcher, to show the slides of his objective?
Okay, wait. Objective.
Oh, yung objective 2 and 3, how did you address that? What was the results? What was your findings?
Sorry po, hindi ko masyadong marinig.
What were the results? What were your findings? Yung to ease the burden of the driver. Recognize the significant role of vulcanizing shafts.
And the significant role of vulcanizing.
Yeah, what were your findings? Yung
Actually,
to ease the
we don't have
burden.
further findings po.
So therefore, these
I think
two
this is one of
objectives
the
of the
limitations.
study were not addressed. Am I correct?
Okay.
Only objective 1 and 4 that were addressed.
I think those two is once the system was implemented po.
Yeah, that's 1 and 4. However, you did not measure whether there was really yung sinasabi mong to ease the burden.
Okay. Maybe we should conduct another study. Okay. That's why in our recommendation, I suggest that conduct a beta testing so that
that's not a beta testing. Yeah, ang concern ko lang talaga is because you stated 4 objectives and these 4 objectives should have been met, no?
Okay.
Okay. Yun lang, Ma'am Cherry. Thank you.
Yes, okay, sir.
Okay, unless parang they asked questions about whether the system was able to help them locate vulcanizing shafts. No? Anyway, we did not see the tool that they use. It's just usability. Anyway, so let's move on. So if there are no questions, we move on to the next speaker, Ms. Villanueva, for the Ms. Villanueva for the support vector machine algorithm in fish kill detection. Ms. Villanueva, please.
Hello, can you hear me? Okay. So my topic is all about support vector machine algorithm and physical detection. So I will play my slide here. So, okay, wait for a second. Okay. So my topic is all about the support vector machine algorithm and physical detection. So of course, the abstract of this study is to demonstrate the application of support vector machine as a feature for detecting and classifying physical event at the municipalities of Agoncillo, Laurel, and Talisay surrounding Taal Lake within the Batangas province. SBM optimization was performed in our language. So the physical event dataset used for, of course, collecting samples for SBM procedure were, of course, the attributes, water quality checker, Lamotte and Hatch test, kits, and colorimeter. Sample objects were tested based on the following parameters or the attributes, such as dissolved oxygen, temperature, carbon dioxide, ammonia nitrate, phosphate, pH level, humidity, weather, and color of water. So the classification results of the sampling site yielded an accuracy of 98%, which confirms the physical event prediction using proper tuning of the SBM parameters. So in this paper, different metrics were used such as kappa, MSE, and accuracy to validate the prediction model. So in my introduction, of course, physical is also defined as the abrupt and significant death of the fish. So this is demonstrated by a voluminous number of fish. So the scope of this study is more on Taal Lake, okay? So, the Bureau of Fisheries Aquatic Resources or the BFAR at Amboling Tanawan, Batangas had been monitored that phenomenon since 2000. So, based on their observations, sulfur upwelling in Taal Lake usually occurs from November to February when the northeast winds disturb the sediment of the lake. So while fish kills are natural occurrences, the earlier admitted the irresponsible aquaculture practice, overstocking and overfeeding tilapia stocks are also the contribution to fish kills. So through data mining approaches, these occurrences event be easily predict using supervised learning algorithm, which is called as a support vector machine. So here, as my related literature, so data cleaning is the first phase in pre-processing to address the noisy data to assure the quality of course, our data. It can be done manually using spreadsheet software, semi-automatic through the aid of data pre-processing tools like Weka. So of course, as my related literature, excerpts of references, research below show how the machine learning, specifically the supervised learning algorithms, have been utilized in the field of aquaculture fisheries. On the other hand, data pre-processing plays an important role to create a great model. So here, as my related literature, Kumar et al. Claim that data cleaning deals with failing of missing values, handling noisy data, and resolve inconsistency in data. So another research is about the Mohammed et al. So it's very useful for database data cleaning. So as you can see here, data pre-processing plays an important role. Okay, so another research is from Makandog et al. So they conducted a fiscal events in Taal Lake. However, they used the Bayesian algorithm to address food environmental security issues. So that's the reason behind why I decided to conduct a fiscal event using the SBM, because they Makandog et al. Used the fiscal event using the natural language, NLP rather. So for the data acquisition, so in gathering the data for the research, interviews were made with the BFAR Tanawan, Batangas City. So the mentioned agency is very cooperative. So they gave us the historical data from the year 2012 up to 2018. So because I discussed the main purpose of this research. So it's composed of different attributes: testing area, weather condition, wind directions, color of water, air temperature, ammonia nitrate, phosphate, sulfide, carbon dioxide, hardness, and water transparency. Their sampling data were gathered as the existing system nilis. Their sampling data were gathered through the assigned chemist personnel through the use of their existing tools, and they recorded that in the Excel format. So in my methodology of this research for the data acquisition, I've done with the interviews with the BFAR, of course, and then I also asked their permission to have a copy of their records in the Excel format. And then for the data processing, I also use the manual data cleaning and of course the feature selection. Of course, actually I use the both manual and of course the Weka for cleaning, because Weka also has ability for filtering the data. And then for the model creation, I use the R data mining, and then I use the split, of course, the split training and test data. And then this research, I use the different splitting of training test data. I use the 80-20, 60-40, and so on. And then, of course, it's also, I also consider the tuning of the parameters of SBM. And then for the validation of model, I use the kappa and MSE, and then for the accuracy. So here, these are some of the historical data sample. As you can see, there is an area, okay, surrounding with the Taal Lake, and of course the weather condition, the wind direction, and the color of the water. So here is another table for additional historical data. And then we have here the pH, ammonia, nitrate, phosphate, sulfide, carbon dioxide, and hardness and dissolved oxygen. This is also this data is recorded by the chemist. Then for the next slide, so this is the schematic diagram of my proposed study in physical prediction. So of course, from the raw data, which I know that the raw data is very noisy or dirty data, I use the data pre-processing and cleaning for, of course, I use both manual and semi-automatic. And then I use the predictive modeling support vector machine in R. So later on, I will show you on how are we going to implement the SBM in R. And then, of course, in testing a predictive model is very important. In creating a model, we have to use the different parametrics. I've used here the accuracy, kappa, and mean squared error. Then for the data processing, the raw data is composed of missing values, of course, because that's the real data. Inconsistent, and it's very noisy. So the data processing were needed before the actual implementation of the model. So the pre-processing of the historical data is done performed manually. Commas and punctuation were also omitted, and uniformity of lowercase and uppercase characters also avoided. And of course, I've also used the missing values were changed into, of course, 0.00 values. And duplicate data were also eliminated. Some of the attributes were changed to nominal value to numeric values. So additional column, I consider that as a class, which is the name event, was added at the last portion to signify the occurrences and non-occurrences of the physical event. So for the creation of the model, after the data pre-processing phases, the researcher execute the creation of prediction model using the R data mining. So in R, we have the proper library for support vector machine and algorithm in R. So first, the data was split into two categories, namely train and test data. In R, we can use the library E1071 to call the support vector machine console. The example codes for creation of the models were listed. Okay, so I have here a variable name. FKE stands for fiscal event. So it's the locations of my of course my data. So I used the split of 80-20% here. So 80% is the test data and the remaining is the 20% for test data. And then I call the library E1071 to call the SBM. So after the model is created, it's ready for the execution of the prediction code. So the last phase is the validation of the accuracy. So different metrics can be used in assess the accuracy of the model. So I've used the kappa, MSE, and accuracy in the study. So, okay, so this is the code and validation of the model in R. So it's so easy to call those metrics in R. So I use the library metrics, and then what you call comparison of the actual predicted, okay, and then the score quadratic weighted kappa, and then the mean squared error. So the researcher used experimental method in doing this research. And of course, here is the testing resources. As I mentioned a while ago, I used the R because R is really good in testing or creating a model in both in data mining or any factor recognition. So I use the comma separated values here. And then for the implementation of the support vector machine algorithm, as I've mentioned, support vector machine algorithm is really good in the two classes only. But based on, I have read many researchers attest that SBM is good in two classes, but the performance of SBM in multi-class is not as high in a two class classification. So here is the functions for the training of data used for model. So again, I mentioned about the library, and then all you need to do is to call the model SBM, and then all you need to do is to predict the model using the test data. So which I've mentioned that I used the 20%. So here is the model. Okay, this is model of the SBM. I've used the SBM type as the C classification, and of course the radial and the cos one. And the gamma is 0.0189. And then the number of support vectors of this data is 66. So here I have here the presentation of my, of course, testing of my model. So here I use the 80-20. 80 is the training data and the another one is the 20% for test data. And then the kappa here is close to 1. So it's really very high, 0.99. And then the mean squared error is 0.021, which is close to 0. And of course, the accuracy is 98%. Then I also use the 70-30 approach. 70% training data and test data is 30%. And again, they have the same kappa, which is 0.99. And then, however, in mean squared error, it's a little bit higher. And then for the accuracy, a little bit lower, which is 95%. Then, of course, the two-third training data and the one-third test data, two-thirds to 66% of my data, 66 rather, and then the 66%, and test data is for the 33%. Again, they have also the same the kappa results, which is the 0.99. And this one is close to the 80-20% splitting of training and test data, which is the 0.034. And this is 97%. As you can see in my code here, I use this one as the 70% and 30% approach. As you can see here in my code for the metrics. Metric is 94% for the accuracy. MSE is a 0.53. And of course, the mean quadratic weight is 0.99. And for the conclusion, so the study found out that using 937 rows of historical data or the instances could enable a machine to learn the pattern recognition between the physical occurrences and non-occurrences. However, increasing the training data can make the prediction model more accurate. So the different methods included in the library in R could easily validate the created various model. So support vector machine algorithm, a supervised learning type of classification, generates a good model and predicting the physical, even though I have only 937 instances. So it signifies that the mentioned algorithm has a good performance in optimization when the declared class attribute is not multi-class category. So I use only 2 classes. So these are my references for this research. And of course, that's the end of my presentation.
Okay, thank you, Ms. Villanueva. Okay, so we are now opening the floor for questions. So
Hello. Hi, Ma'am Cherry. Yes,
Yes.
I'll ask a question. I appreciate your presentation of your research output. What is your ground basis on selecting support vector machine, especially on the discipline or the fish kill detection or any similar studies? Did you conduct any literature review on this? Yan lang po.
What is my main reason why I choose SBM? Is that your question, sir?
Yes, correct.
Actually, I've used SBM in different researches, and it has a very good accuracy rate, because many researchers attest that SBM plays an important role in the 2 classifications only. But if you're going to apply that in the multi-class category, it will not generate a very good model. So actually, I use that in my different research.
Okay, I actually do agree because I conducted a research which is similar to this. However, I utilizes more than one classification algorithm. So yun lang po, Ma'am Cherry. Thank you.
There's another related question, I think, here. Although I don't know if The question from Jay Katapang is, why was MSE used on a classification problem? But although this is supposed to be support vector machine, right? I do not know the MSE there, no?
Mean squared error.
Okay. For classification? Yeah. MSE can also stand for mean squared error. But for the, why was MSE used? Yeah. That was the question.
MSE use is to verify.
Not necessarily for the use, why was it used to, for a classification problem? It's supposed to be used for a regression.
Okay.
That was the question.
Okay. Can I answer that question? Okay. So the reason behind why I use a different metrics, why I use the mean squared error, is to, to differentiate what will be the performance of the SBM in different metrics. So based on my research that I have read, mean squared error, if your score is close to 0, meaning to say that your model is really good, whether you are using the regression, whether using the classification method. So that's just only my answer for your question. So to validate the good model, so if we are just going to use the accuracy of the model, so I guess for me that's not enough.
I hope that answers your question, Mr. Katapang. No? So si Ma'am Salido has a question. Go ahead, ma'am.
Miss Marcel, ask ko lang.
Hello, ma'am.
Hi.
Hello, how are you?
What did you do sa missing data?
Yes.
And how much of the percentage ng data mo yung like may missing data?
Okay. Thank you, Ma'am Julie. So my percentage of my missing data is 5%. So that's the reason why I use this replacement of 0.00. So for the padding, so if you have less than or 5% missing data, you are allowed to replace the missing values into 0.00. So that's my
That is
answer.
for all of your parameters?
Actually, yes, ma'am. 5% of the entire data, rather.
Di ba may mga pH value ka doon? May mga humidity, may temperature?
Yes, ma'am. Kasi, ma'am, ang reason doon is may mga part na hindi sila naglalagay talaga ng wala silang data, actually. That's the main problem. That's the reason behind why I use the 0.00 as the cell padding, or translating the value, the missing values into 0.00.
Okay. Thank you.
Thank you, madam.
Yeah, I remember that some of our students before also parang proposed something similar to this, yung water study. Pero ang biggest problem talaga nila is the data, yung availability ng data and all of those missing values, because it will affect so parang we stop parang pursuing that because of the hindi reliable yung data if there are a lot of missing values. I guess yun yung point, kasi 0 might mean something So,
yes, ang pH kasi pag naglagay ka ng 0 is totally different from if you're going to do it statistically based on the data given.
Yes, ma'am, I appreciate your idea. But based on my result, I also consult the chemists regarding with the prediction model. So that's the assurance that, of course, my model is not really, for me, it's not perfect for now because I have only 937 instances. But later on, as I get another data, I will attain the ideal model, because I have only 2012 to 2018 for this record. So I guess my solution for that is retraining the model. Yes, I agree with you. There's no model could be perfect. So based on the chat of our who joined in this presentation. So I agree there's no model could be perfect. So but we can achieve the ideal model based on the available historical data.
I think you better ask yung mga sa kumukuha talaga ng data kasi usually hindi sila nagre-replace talaga ng zero ang pagkakaalam
yes,
ko.
ma'am.
Kasi we also did study on weather forecasting and some of the
Yes, ma'am.
data
I
set.
agree with you.
No,
So I can, yes,
hindi
ma'am.
talaga siya applicable yung pag-zero in ng lahat ng mga data. Especially pag it involves prediction for mga page value, for mga different parameters that it will involve that one.
Okay, ma'am.
Suggestion ko lang.
And
Kasi,
thank you, ma'am. Thank you for your constructive criticism. So I will follow your suggestion, madam.
There is a last question here, since this is a classification from Charlie Villarba, since this is a classification application, what is the generalization of the study based on the result?
The generalization of the study that as a support vector machine algorithm generates a good model. So again, however, we are really rely on our available historical data set. So based on my experiment, so I see that SBM performs well in classification of fish kill and non-occurrences of fish kill event.
Okay, maybe you have to document yung properly, no? Sa paper siguro yung comment ni Ma'am Juliana, no? So do we have other questions?
Ma'am Cherry?
Yes, Ma'am.
Ano lang po, more of suggestion din. Kasi kung meron tayong mga data set na may mga missing, so I agree with Ma'am Julie, hindi nga po usually talaga pinapalitan. Maybe you can try interpolation. Kasi kung meron ka namang previews and yung next, tapos may mga missing values. Again, this is to be consulted with the expert in the field kasi hindi rin naman po siya applicable for certain problem. So, for example, sa stocks, kung meron kang mga missing days, hindi mo siya pwedeng walang value for those days. So,
Yes,
may
ma'am.
mga rules sila na ina-apply. So, yan lang po. Usually, may dalawa po yan pwedeng interpolate o kaya naman kung ano yung last na na-collect. I forgot the scientific term for that. Pero yung last na na-collect, yun yung i-replicate mo. Parang i-maintain mo siya as the current value until may ma-encounter na bagong data. Parang ganon. So, usually po, again, this is dependent on the domain of the field, yung application nung study. Ayun lang po.
Thank you, ma'am.
Thank you, Ma'am Ann. So, any more questions? Okay. Parang none. Okay, last call for the remaining presenters, no? We are supposed to have parang 3 more. I do not know if do we have them here? Last call for the remaining presenters. Sir, may I request my co-facilitator, Sir Mark and Ma'am Sheena, last call to find our remaining presenters?
Yes, ma'am. We're trying to search po sa attendees.
Okay, that's why I did not stop the presenter because I know that there are no other presenters on queue, but maybe they are still here. Okay, last call. Having none. Okay, so the certificates will be provided to all our participants in e-certificates. So I hope that you were able to encode your full name properly when you registered for this event. That will be the basis for the names in the certificates, as well as it will be emailed to the email addresses that you have parang encoded also in the when you registered for this event. We would like to thank all our speakers for today. We would like to thank all our participants, all our panelists. I hope that you will still be with us next week. Next week, we have 2 invited speakers. We We will have again another professor from Southern Taiwan University of Science and Technology, plus another speaker locally, from CIT University. We'll talk about CIT's experience in terms of robotics education. Plus, we will have how many is that? We will have 3 paper presenters in the morning, and in the afternoon we will have all of the poster presentation. To our poster presenters, we highly encourage you to create short videos that will make sure that you can present all of the things that you want to say regarding your poster for 3 minutes, and then so that we will play them. Guaranteed no technical error or anything like that. You can present it in full so that we can also facilitate and maximize and manage our time properly. Okay? So, Sir Jimmy, you want to say something?
Wala na, maraming salamat. Congrats sa lahat. Siguro kung meron pang presenter na hindi naka-present ngayon at gusto mag-present next time, pwede nating i-consider kung may time pa next time. I think meron naman yata.
Okay, actually, to those who were not able to present, my advice is to create a 15-minute video of your presentation. Okay, and then if we have time, we will play the video. I think that is the fastest that we can do, and the best that we can do for the remaining presenters who were not able to present today. So once again, thank you very much to everyone for coming, and hope to see you again on October 16. Goodbye.
Bye.